Hey everyone, how are we doing? We're about to hear double audio. I fixed it just in the nick of time. How's everyone doing? Just started up the video here. I think we have, it said 7 people watching. Do we have, is it 0 viewers now? We should be streaming. We should be here. I saw the stream going. It said 7 viewers. We got 4 viewers right now. If you're in the chat, feel free to say, hey, you get to pick what we do. This is, you decide what we cover for statistics. So what do people want to cover? What topics should we talk about? Let's see who's here. Hey, Layla, good to see you here. I'm always worried. There was one time last semester, or last, I think it was mini term, a year ago now, where I started streaming and I wasn't actually streaming. And then I was talking to students and I was like, how's everyone doing? And everyone in the chat was like, what's going on? Canvas content 2. Can we do chapter 4, homework and quiz and Canvas content 2? We've got 2 votes for Canvas content 2. Kylie, good to see you here. Looks like Canvas content 2 is what we're going to do. So let me go over here and get Canvas content 2. We'll do 2 versions of it. So Canvas content 2, we got 2 votes for that. If you're here, say hey and vote for what you want. Good to see you here, Dean. So good to see you. See, when people have like a frog avatar or something, then I'm like, I know who that is. So good to see you. Simran also votes. So does William vote for Canvas content 2. Awesome. Let's hop over here. Let's go to, I'm getting it ready as we're talking. Good to see you, William, Dean. Dean, so good to see you. Dean, did you took 201, right? My brain, like, I'm trying to remember. It's so much easier when I see students in person. And then with students in person, you know, I get to see them, I get to say hey. But when we're online, I'm like, I remember you. I think it's so much easier in person. Now I'm sad. I'm sad. Let's play the happy sad music. This makes me smile. Happy sad music. Just 320. There we go, Dean, right there. I should have remembered. I remember the white frog right there. It's my happy sad music. Let's go over here to Canvas content 2. Let's do this. Okay, we're here on Canvas content 2. Got our music playing, ready to go. We're going to do 2 versions of it. There's lots of different versions you could get, so this will help out right here. These are box plots. Now, these are multiple box plots, so this is a what display of variables. So I want people to think here, this is a what display because we have side-by-side box plots. So we see here price, which is how much did you pay for an item, and vegetable, what vegetable was it? So you must say, oh, we've got this variable, we got this variable. Brian, this is a what display of data. So because we have price and we have vegetable. So what are you noticing if we say, what was the price you paid? So this person paid a lot for some broccoli by the pound. We had some snap peas were a lot cheaper. So it's what vegetable did you buy and how much did you pay? Like you'd say, oh, yesterday we went to Publix and we paid $1 for some broccoli by the pound. Then someone else was like, well, I went and bought some okra and I paid $1.20. This is bivariate, William. Great job right there. This is a bivariate display. The way this data would look, sometimes I think it helps to understand how data looks, is you would ask people the following questions. You'd say, what vegetable did you buy? You'd say, what vegetable and what price did you pay? So you're going in here, and I'm just going to put in like dollar amounts. So you'd ask people what vegetable they bought and how much did they pay. So you got here broccoli, okra, snap peas. So I'm just quickly abbreviating right here. Oh. So broccoli, okra, snap peas, all these things right here. You got the vegetable, you got what price they paid, analyze, distribution, or fit y by x, excuse me. Price is the y variable. Vegetable is the x variable. You don't have to do all this. We're just kind of going a little extra right here. And now you can notice, what do you get? Does everyone notice the similarity right here where we have side-by-side box plots? And it's the same sort of idea right here where we're viewing what vegetable did people buy and how much did they pay. And once again, when you look at the data, someone would report to you, I bought broccoli and I paid $3. Another person bought broccoli, they paid $2. So we have here 2 variables collected on what vegetable did someone buy and what price did they pay. So which vegetable had the highest selling price? What do people say? I think you got this one. This is a side-by-side box plots, which it's multiple box plots side by side. What vegetable had the highest selling price? What vegetable had the highest selling price? You have to be careful. It's got a little bit of a trick because you might look at that, but then you should look at this over here. So the whiskers show you the highest value that's not an outlier. It's broccoli. Yep. It's going to be broccoli. Even though this is an outlier, That's kind of the trick to this question. Is some people might say, oh, it's okra, but no, broccoli had an outlier up here that is unusually high. So I didn't really make anything crazy with my display of data. There were no real outliers. But if there is an outlier, it is part of the data set. So make sure to include outliers. That's a big thing we'll talk about when we do this lecture tomorrow. Is we'll be like, don't forget to talk about outliers. This was the highest value. Someone paid like $1.52 or something for broccoli. Which of the following is a display of bivariate quantitative data? Ooh, tricky one. Well, we've talked about two of these, and we haven't gotten to this yet. So which of these two can you eliminate right here? What is one of the ones you can eliminate right here? And here, I'll start writing on this. We review in a really good way right here. Don't just look for the right answer. Look to make sure you know why it's the right answer. So which one of these did we talk about today? We talked about two of these today. We talked about a bar chart. Bar chart is like pie charts, and that is for one categorical variable. His bar charts and pie charts are the same sort of display of graphic, like they can display the same thing. So that's one categorical variable, which we want a bivariate. We want two quantitative. So that's not going to be the right answer. What else did we talk about today? We spent a lot of time talking about this, talking about the shape center spread of it. We talked a lot of time talking about the shape center spread of this, which could be a dot plot, which could be a stem and leaf. Dot plot, stem and leaf, histograms are one quantitative variable. So we've eliminated down choices. A scatter plot looks like the following, like your height and your weight. A mosaic plot looks like the following, where you have like, do you live on or off campus, and do you own a pet? So this would be on or off campus. So we'll put here campus, and we'll put here pet. Which of these looks like a bivariate display of quantitative data? Histograms are going to be things like your height and your weight, where mosaic plots are going to be things like, do you live on or off campus, and do you own a pet? Scatter plots. Scatter plots are two quantitative variables. We'll have a condition QQ straight enough, no outliers, but a scatter plot is two quantitative variables. What do you notice a mosaic plot is? A mosaic plot is something like, do you live on or off campus, and do you own a pet? A mosaic plot, which it kind of looks like it, if you look at the mosaic plot closely, it kind of looks like we've almost just taken some what's for it. When you look at a mosaic plot, well, that's a pretty badly drawn mosaic plot. If you look at a mosaic plot, it kind of looks like almost like a what? Does everyone see it? Well, a mosaic plot, it's going to be two, oh my gosh, I made a mistake. Mosaic plots can be two categorical, and a scatter plot can be two quantitative. So a mosaic plot is two categorical variables. So to make a mosaic plot, and I'll make one right here quick to show it, and this is a really good review. Like the things we're doing right now, if you're practicing this up, if you're doing these examples, to make a mosaic plot, you have to go here and you have to pick something like gender and if somebody has broken a bone. So notice both variables are what? Yay! What's up, Lucy? Good to see you here. Lucy just took 320. Great to see you here, Lucy. We got a whole... Lucy, if you were to offer any advice for my students in mini-term right now, what advice would you offer them? If you offer my students any advice here in mini-term, what advice would you offer my students? And thank you so much for swinging by, Lucy. Lucy appears. That's worth 50 bonus points right here. And also, we had another former student. Two categorical variables. So two categorical variables, and we see here males a little bit more likely to break bones right here. So two categorical variables. But if we did something like two quantitative variables, like let's say here, Lucy's going to give some amazing advice. Maybe she just went by and say hi, or I think so. And let's go right here. Let's do GPA. Oh, there it is, the pet's owning expense. I think the button just bumped against the wall. So here we are. Or my neighbors are like, be quiet. And here we are right here. If you look, this is a pretty bad, especially Lucy just took 320, and they can tell you that this right here is a little bit not good of a scatter plot. But why is this a scatter plot? This is two quantitative variables. Two quantitative variables. So with the two quantitative variables right here, you can see if there is a relationship between them. But notice how we have two quantitative variables. So really, really important. Yes, thank you so much, Lucy. Attend class live, participate in chat, even if you don't know the answer. Ask for help when you're stuck for more than 5 minutes. Vols help vols. Thank you so much, Lucy. That is amazing advice. Please take Lucy's advice right there. Take Lucy's advice. Even if you get answers wrong, let's take the advice right here and see if we can do this. What is the probability of a student being born in Tennessee? That's all we're trying to figure out. What is the probability? Who can show the mathematics right here? Give it a shot. What is the probability of a student being born in Tennessee? And this is a contingency table. So this graphic is called a contingency table. And that is some really good advice to take. So we're going to take it right here. What is the probability a student is born in Tennessee? Don't worry about getting this wrong. See if you can show the mathematics. What is the probability a student is born in Tennessee? Watch me get it wrong when I check my answer. What is the probability a student's born in Tennessee? So what we're actually looking at is a marginal display here. I think that might be right. Sam, good to see you here. I'm definitely going to check out Orange, that anime. Let's see. 524. That might... Oh, wait. Up. So 524 is that a student is born in Tennessee and they're not in honors. Did it say that? So this is chapter 3 and chapter 4, I think, that we're doing. We're working a little bit ahead right now. So I think correct. So this is what is called a marginal display. We'll be talking about this a lot tomorrow. This is the display in the margins. We're throwing Sam and everyone 20 points right here for taking a shot at it. So great shot right there. Do not worry if you get it wrong. We're here to practice. But does that make sense right there? Great job, Kylie, right there. This is 574 divided by 923. That helps me when you put it on the screen. We'll do another version of this. And then we'll do this for like 5-10 more minutes. And then we'll do another 574. There it is, 62.2. Thank you. Answer should be like this. So 06.22. You bet it's 201. Definitely, it's good practice too. So, yep, this is all 201 right here. We got some superhero stuff, which we do this stuff in 320 also. This is the start of 320. So, at 201, if you can do this, you can do 320. Oh, you're about to see some points right here. Above is a contingency table of comic book superhero abilities. What is the percent of superheroes? Oh my gosh, it's a tough one. Lucy's just reached the new levels. What percent of superheroes were not from the publisher DC? So who here can figure out what percent of superheroes were not from DC? And then we'll do one more version of this, and then we'll switch topics. We'll do one more. This is another contingency table. What percent of superheroes were not from DC? So we're also looking at, I'll highlight what we're looking at. What percent of superheroes were not from DC? I know, right? I am wearing a Captain America shirt today. It's perfect timing, right? I think great job right there, Layla. I think Layla is correct, and Layla subtracted. I'll show the mathematics, but this is taken from not from DC, so we need. So that should be it right there. Is that it, Sam? That looks about right. Great job, Sam. So please tell me if I get something wrong. There we go, 0.663. 0.663. There we go. Great work. Remember, these are basically test questions. Ooh, I think this one gets people. This one is tricky. This is the one I get emailed about a lot. Are you ready to do the very hard question? Now, here is where people get tricked on the wording of this. Let's be very careful. What percent of respondents choose dislike of the extreme dark chocolate flavor? So we're saying of the people, so we're saying of these people who tried extreme dark chocolate, what percent of them disliked it? That's another way of phrasing it. Like, for the people, I tell you what, Lucy, if you write it down, because I do have to reset points, I will give them back to you. Are you taking 474 with me, though, Lucy? You keep your hours. I think Layla just got it. If you write down your points, and at the end of the semester, I could give them all back in 474. Like, I would always take someone's word for it to be like, I had this many points. So write down your points. And like, if you said 30,000, I would do that. I can't. I'd bump you to. I could. Yeah, you're right there. Yeah, write down your points. And at the end of 474, I'll give you back the 30,000, and we can see like what you get to with all of them. So of the extreme, great job, Layla, right there. Of the extreme dark chocolate is saying only people who tried extreme dark chocolate and what % of them disliked it. So we're going to use only these numbers. Oh man, look at that decimal changing right there. Did I change this in the... Did I fix all these? Oh, I fixed some of these. I don't like the way it gives like these multiple answers. I think I did fix this in the blueprint. We have a blueprint course we use. So I try to fix them. It's going to be these numbers. I try to fix them so it takes either or answer. I'm so excited for 474, Lucy. Like, this is going to sound... should I see if it's got it? That's 52.76. Did Brian change it? Should I tempt it? Should I tempt fate to see if I changed it and fixed it in the blueprint? Ooh, you see I didn't enter this one in the way it wanted me to. Let's see, and let's see what happens. Because I want to see if I updated these in the blueprint. Because you see, even I got tricked by this. Because it does tell you how to enter it, and it's so easy to make these errors. And let me point this out, if I were to get these wrong, so I do want to answer these incorrectly or the improper format, I might miss 2 questions right here. I missed 1. Let's see which one I missed, and it's probably doing it because of the formatting. Does it not show me the right answer? Really? Can I go back in time? See, it did accept this one. Oh, that's the one where we entered incorrect in the right way. Oh, it's locking me. It says, no, you can't do it again. So it won't let me redo the question even in the preview sense. And I don't think I can see the right answers, but we did do it correctly. If you feel like you got it correct, please email me. I do correct things. Lucy, tell them, do I give points back? If you miss something, do I give points back? If you truthfully got it. So if you truthfully got it, do I give points back? Like if it's like, yeah, there was a decimal thing or something, will I give you points back? And Lucy will, yeah. Please just email me. If you think you were unfairly had points taken away from you, just email. I'll be like, sure. To that person right there, if that was you and you got 8 out of 10, can you do the one that asked about the 70th percentile of the French team? Yeah, let's do one more version of this. Here, I'm going to hop to space. So we need to find the one that asks about the 75th percentile of the French team, and we'll do that version of it. So I'm going to find it. And then, oh my God, I'm showing like, here, let me find I'm just going to show every test question. I literally found it right now. Are you ready? Here we go. Let's do this, Layla. So here we are. What is the 75th percentile? So when you look at box plots right here, here's how box plots work. Box plots are going to show you the 5-number summary. So this is going to be something right here. Let's put a mark here, a mark here, a mark here, a mark here, and a mark here. Number what is what for these box plots? Let's go with number 1. Number 1, where I've marked number 1, is the what value in this distribution. Number 1 is the what value in this distribution. Number 1 is the what value in this distribution. Number 1 is, it's the lowest. It's the minimum. Great job right there, Sam. Well, then what do you think number 5 is? Number 5 is going to be the what value in the distribution. So if you go to the very top of it, number 5 is going to be the what? The maximum. How about that middle value right there? What about the middle value, the value in the middle of everything? How about that's the median? The median is the line in the middle of the box plot. So then what is number 4? Because it's kind of like if you do this, if you were to draw quarters right here, and they're not always evenly spaced out, but if you were to draw quarters, it's kind of like what we're talking about today. Yep, definitely an outlier right there. Great job, Lucy. 70th percentile. Correct. Great job right there. This is the 75th percentile, also known as Q3, because 75% of the data is below it, and this is Q1 right here. And so Q3 is when you've achieved 75% of the data is below it. And so that the upper quartile would just be above it. Does that make sense to everybody right there? Does that visually, like when you see that right there, you're like, okay, the maximum for Croatia, that's what it is. Croatia, I know Croatia. The maximum for Croatia is an outlier. This is just, this line right here is just the highest point that's not an outlier. So would it be 190? Probably. Let's take a look. It's a good question right there. So which one does it want for France? Is it the, yeah, great answer. That'd be 190. Yep, that should be it. We're going to get 100 this time. So it'd be 190. Great job right there. What vegetable has the highest selling price? We did this one earlier. So the vegetable with the highest selling price is going to be broccoli because of the outlier. Don't forget outliers. That's a big thing people get caught on. So what percent of superheroes were not from the publisher DC? So we need to take, this is one we did earlier. This is version 2. So check out the longer solve of this that we did a moment ago. We're going to get 100 on this one though. We're going to subtract from that. These are the not DC superheroes. And then out of the total, and then it wants it in a format like this right here. I times it by 10. There's times 100. So, and it says to 2 decimal places. So that rounds up. And I'm going to check the way those are working. What percent of the responses of choose, what percent of responses choose dislike of the extreme dark chocolate? So we're only looking at the extreme dark chocolate. And we're going right here to dislike of extreme dark chocolate. And we need to do it in the following format. So, and it says to 2 decimals, 52.76. And then last but not least, what is the probability of a student being born in Tennessee? And then we have to do this one as a decimal. Nothing like switching decimal formats. So out of all students, what percent were born in Tennessee? 574 divided by 923. And this one is as a decimal. So 0.622. And if we get one wrong, I'm seriously going to be wondering what we got wrong. We did not. So yeah, could you do the probability of a student being an honors student version? Yeah, here, let's look at that. So can you copy what the question says and put it in the chat? I'll use this table. Make sure your table is the same, and then we'll switch topics here. So you're saying, what is the probability of an honors student being born? Like, so tell me what you have right here. It sounds like a conditional distribution, like given someone's an honors student, what's the probability they're born in Tennessee? So given someone's an honors student, what's the probability? I think this is what you're asking, like, of the honors students, what's the probability of a student being an honors student? What's the probability of a student being an honors student? Oh, wait, what's the probability of a student being an honors student? So what is the probability of a student being an honors student? Okay, figure it out real quick. What is the probability of a student being an honors student? So if it just says, what is the probability of a student being an honors student? Go ahead and figure it out right here. So you only want to focus in on the honors stuff. You only want to focus in on honors, yes, no. Is it either? Yep. We can remove them if they're misentered. Great question right there, Layla. We can remove outliers if they are like bad data. You generally don't remove them. It's not a good idea to remove them. And that's what tricks people sometimes. But you can remove them if they're like misentered, or you can do the analysis with and without them. But you don't really want to throw out outliers that much. You don't want to just be like, outliers, just toss them out. You don't do that. You can sometimes remove them. It is sometimes okay. That sounds about right. Great job, Lucy and everyone. As we're only looking at honors students, this is called a marginal display. The marginal display is the display in the margins. We'll be covering this more tomorrow. But who's gotten hundreds on their Canvas content already? Who's like 100, done with it? Maybe did my second version. At the end of class today, someone said, and Lucy, thank you for hanging out. I love the people who just come by here and just hang out. I mean that. Like, you're welcome to swing by anytime. One of the questions on the quiz asked if their son has a good reason to remove them. And then put yes. Not to directly answer the question, but awesome. No, I really mean it. I'm so glad you're here because it's like it's great job, Layla. I try to tell classes, so I'm glad you're here to like, one, encourage them just to hang out and all that stuff. Like, when I have my physical office, former students come by who are not even in my class to be like, I'm just here to hang out and eat lunch, and I'm just here to meet new students. And I'm just like, yeah, hang out. Just like people do that with my office when we have my office. I think people are saying it's going to be 0.07 because it's going to be. But Lucy, your encouragement to them on what to do is what's most important, because I want them to hear it from other students. Because what I notice when people do poorly in these classes is that a lot of times it's just like not doing the work, not showing up, not engaging the class. And the more I can get people to engage and talk and interact, and I sent that email to your class and I really mean it, and I actually mentioned it during the presentation I gave this morning, is that it was your guys' class that was so interactive. Oh, I can fix that. I can fix that. Layla, send me an email. I'll fix that. I believe you mistyped it. Send me a quick email, Layla, and I'll fix it after office hours here. Just be like, Brian, I mistyped this. Can you fix my quiz? Usually, unless someone sends me emails like every assignment and is like, I mistyped this. I typed 1000 and I meant to type 24.32. I'll be like, I'll be like that. No. Yeah. Mubot appears in this universe now. What should we do now, everyone? It is your call. Mubot, you so
I am Mubot.
yeah, you just do what you want, right, Mubot? I don't know. He gives out a lot of points, so we got to give Mubot credit for doing what Mubot does. It is your call. Chapter 4 quiz. Yes. Oh, thank you so much, Lucy. Yeah, I was trying to find the right words to email your guys' class and say, I really think it is the class that made this class so great. I mean, that sounds redundant. It's the class that made this class so great. But what I mean by that is, I can only do so much. And Lucy knows, Lucy, I mean, I don't think, during class today, a roommate joked with another roommate, and they were making fun of their roommate, and I didn't know it. And so I always want people to know we have like a positive environment. Yep, Simran, they definitely should. Great answer right there, Simran. They should definitely have the same horizontal access. So two people were joking in class and I didn't know it, and I was kind of like, hey, don't do that. And they were like, oh, that's my roommate right there. And I was like, oh, okay. I didn't know that. I don't want anyone to ever be mean to anybody in class. We're here to make a positive environment, to have some fun, and to learn, and to crack some jokes. But once again, we always stay positive and we always help each other out. But no, they were totally positive. They were having jokes, but then we didn't know it, or I didn't know it at least, because I don't know everything. I don't know everything. Positive vibes. That's what we do. I don't know. I want people to come out of this class just feeling a little happier each day, to be like, just like makes their day a little bit better. That's what we do. Which question are you working on, Layla? Is there a specific question that you had for Chapter 4 quiz? I've got Chapter 4 quiz up. Is there like a box plot one, or which one are you working on? There's 21 questions. We can do any of these 21 questions. Who's gonna yawn? What of these 21 questions should we do? I can pick a random one right here. We could do this one to start. Let's sit over here. Let's take a look. While people are looking for a question to do, I'm going to do this one right here. Let's do it. Okay, here we are with the first question on Chapter 4 quiz. Let's do that. We'll do that one next here. You got it, Layla. So, what is the range of sugar contents? Well, the range is just going to be the max minus the min. Who can tell me the range right here? Yeah, Sydney, let's do that. We'll do that here in a moment too, Sydney. We'll do the kindergarten one, or the fourth grader one. There's a kindergarten one later on about heights. And so, define the quartiles. Definitely use jump. We can do one of those if you want, Sydney. So if you put the question in the chat, I'll definitely do it. 63, max minus min is the range. There you go. You can see it right there. Max minus min is the range. So the range is 63. Describe the shape of the distribution. Just put 2 letters in the word. Put 2 letters in the chat. What do you notice right here about this? So don't click on the answer chat. What do you notice about this? There should be a 2-letter word you put in the chat right now. This is a what histogram? Something modal, bimodal. Great job right there. That's a bimodal histogram. What aspects of the cereals might account for this shape? When you look at the shape, great job right there, Layla and Sam. When you look at the shape of this, what do you notice about, this is how much sugar is in the cereal. Like we measure like how many grams of sugar in there, or percent sugar. I'd love it to have a 64% sugar cereal. It's like sugar coated sugar. These are more likely to be children's cereals like Captain Crunch, Fruit Loop, Twix cereal. There's no Twix cereal. But over here, you've got like Fiber One. Yeah, exactly. Cereals tend to be either sugary or healthy. And I think that's going to be it. Sugar content's very greatly among It's more that there's either like the good healthy ones and the really bad ones that I love. Are all children's cereals higher in sugar than adult cereal? The answer is yes. Here's the lowest one. Oh yeah, let's do that. We'll do that one. We'll do Layla's question, then Sydney, you got it next. Here's the minimum for children. Here's the maximum for adults right here. So this is the highest adult sugar content. This is the lowest children's sugar content. So the answer is definitely yes. Which group of cereals varies more in sugar content? Well, if you look at the ranges of them, which there's two ways to look at the variation right here, these look similar in range. What I mean is like the length of this box plot is the length of this box plot. But look here, this is the middle 50%. So this is the what of the box plot. This is the middle 50%. So this is the three-letter word. It's the middle 50%. Bingo, Layla, great job. And we covered that today. We talked about the IQR. So there's more spread to this. There's more variation to this because it's spread out a little bit more. So although the ranges appear to be the same, the IQR is larger for the adults. There we go. I think we got it. I'm so worried. We got it. Great job right there. Let's do the next question. Layla had the next one. And then Sydney will do your question next right here. Let's see. Layla's question was about the fourth graders. Let's go find that. Just 1 second here. And feel free to ask a question at any time because we'll just put it in the order. Oh, other kid. Oh, yeah. No, thank you so much. Yeah, no, we're so lucky to have gotten that. We're working on that right now. It's been really hard to work on that with being in Texas and like basically I'm trying to get it prepared and everything, but I'm hoping we can get people up and running with it for the fall. So over the summer, I'm going to need to make some big steps in it, but COVID just really flipped everything on its head. But yeah, I'm hoping we can have people using it for the fall. So I'm going to put out a big thing for it and try to get people to use it in the fall and say, hey, you can use this in the fall. And so I'll be talking to some fellow educators at UT. Thank you so much, Lucy. I was so honored to get that, and it was really awesome. That was one of the one UT grants, and that's awesome. I've had so much fun working on it, and we've got the cart basically ready. I haven't even seen it because we've been ordering it all. Like it's all come in. Dwight and other people have been setting it up. I'll get to see it when I fly back to Knoxville. A fourth grade class has a reading diagnostic test. And what do we see right here? Here's the 5-number summary. So it's important to know what this means. If this is the 5-number summary right here, what do these grades represent? What do these grades represent? Yeah, you bet. We'll do Sydney's question, then we'll do that one next, Layla. That's the perfect thing to ask. That's the perfect way to say, like, can we do this next? And then we'll just put it in line and tell me if I ever forget one. So what are these scores right here for the boys and for the girls? What do those scores right there represent for the boys and for the girls? So this is a 5-number summary. This is a 5-number summary. The 5-number summary is best when you draw 4 quarters. And you know what? Let's put them between here like they are right here. So the 5-number summary. Actually, you know what? Watch this. 1, 2. No, I have to do it. Okay, here we go. It would be here, 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 and here. There we go. So then the 5-number summary is going to go here, 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 and here. The maximum, exactly. So the 5-number summary is broken apart into quarters. So you can easily remember the max and the min. Those are the easy ones. Now, what is the middle number called? In the 5-number summary, the max and the min are the lowest and the highest numbers. What is the middle number called in the 5-number summary, where like the middle 50% of the data is the 50th percentile? Not the middle 50%, but the 50th percentile. The 50th percentile is going to be what? What do we call the 50th percentile when we do the 5-number summary? The median. Great job. And then, guess what? Who knows what we can call this when we've added up 1 quarter? Who knows? Let's just crack me up. Well, the IQR is here. Sam, you're on the right track because the IQR is what we're going to find when we go right here and we call this Q1 and we call this Q3. And the IQR is going to be this distance right here. That's going to be the IQR. So that's just the range of those values. So you can actually compute the IQR for this, and the IQR right here would be 1.3. Does that make sense how I'm finding the IQR? I'm just taking the distance of these two numbers right here. I'm just saying how far are these numbers, and you can see that yep, great job, first quartile. Yep, Q1, first quartile. Does anyone know another name we could call the median? We don't usually call it this. I see it called this every once in a while, though. Think about Q1, Q3, and what could the median be called? Some people call the median this. I don't call the median this. What is another name for the median, which sometimes people use? I don't like calling it this, but people could call it this. What is another name for the median? Q2, great job, yep. It can be called Q2. So the median, because it's the 50th percentile, and just think about this, 2 quarters. Like at this point, you've added up 2 quarters in the data. At this point, you've added up 1 quarter. At this point, you've added up 3 quarters. And so great job, Sam and everybody. Another 20 points out to the chat right there. But understanding why we use this terminology helps. And then understanding what the IQR is all this good stuff. So let's look at the question. We've done a good review of the concept right here behind it. And which group had the highest score? Was it boys or girls had the highest score? Was it boys or girls had the highest score? So this is the maximum. Is it? Yours. Make sure to answer. Make sure to answer for yours. Yep. Which group had the greatest range? So the range, the boys' range is really easy to calculate. The boys' range is 3. The girls' range is 3.4. To get the range, do the max minus the min. So you go here to max minus min, and there's the girls' range, and the girls had the greater range of that right there. Which group has the greatest IQR? Remember, just make sure to use your review sheet. The IQR is right here. That's how we calculate the IQR. Can anyone see what the IQR for the girl range is? Oh, no worries, Sam. We'll keep recording this right here. Check it out later if you want. Thank you, Sam, for swinging by. So what is the IQR for the girls range? And for me, it is boys have the bigger IQR. Girls is 1.2, just the distance. And so, Layla, what's really great right now, do you just look at these numbers and do you just pretty much do it in your head? This is when you can calculate IQRs properly and you just look at the numbers and you just say, oh, that's that far away from that number. You just say it's just the distance. That's what the IQR is. It's just how far away are these two numbers? And the range of the middle 50% of the data. So hopefully that's what I want people to realize when they do the IQR. It's just a range. It's just the distance two numbers are away from each other. So it's just like the range of the data, which would be calculated by doing those numbers distances in yellow, but the pink numbers are the IQR distances. So the guys have the bigger IQR of 1.3. Which group generally did better? Ooh. Right, I'm writing it down now. Which one did you write down? The girls did better on the reading test because the median for the boys was higher. We only have medians, right? The boys had a higher median. The boys did better on the reading test because the median for the boys was higher than the medians for the girls. Yeah, that's all we can compare right now. This one's the tough one. Okay. This is the one students usually get wrong at the very end right here. If the mean for reading for boys was 4.9, then for girls was 4.3, what is the overall mean for the class? Okay. This is the question that most people miss. And let's explain. Okay. How many boys were in this class? How many girls were in this class? For this data set, there were 15 boys and there were 11 girls. The 11 girls had a mean of this, and the 11 boys, or the 15 boys had a mean of this. So what you have to do right now is you have to do the mean, but you can do it a few ways. Like theoretic, yep. So it's gonna go towards the boys. Like I could guess, because I think it wants it to one decimal. It's gonna be about 4.7. That's my guess. But when you do this, you would have to go right here, and there are 26 total students, I believe. So there's 26 total students, and then we have to take 26. And I don't think we have any test questions like this. I don't know. The rest of this test question is awesome, and then this one's like the hard part. There we go. So we're basically multiplying it by how many students there are with that average. So we have to go right here and go 4.9 times 16, and we'll copy that. 4.3 times 11. Add those together, divide by 26, and there it is right there. It's 4.83. Sounds about right. 4.8 rounded. I said 4.7, I would have been wrong. So 4.8, does it say to one decimal? There we go. Is it going to be that really? I guess. Let's find out. Oh, I think I did something wrong. Oh my gosh, what did I get wrong? Is it this one? What did I do? I got that one right and really was accepting both those answers. Wait, round to one decimal. Can't be this. Good, that's right. The boys had the greater IQR. They had an IQR of 1.3. The girls had the great... Wait, is this still wrong right here? The overall mean. The boys had the highest score of a 5.8. The girls had the greatest range of 3.4. Do you see it? It's got to be this then. It is this. Did I just mix up the boys and the girls? So it's not accepting that. Round to one decimal. This is weird. I think it's like messed up, which I've rarely ever seen. It can't be 4.6. No way. Wait, what? Okay, I really must have made a mistake on my mathematics. Okay, let me check my mathematics right here real quick. You ready? Do you see it? I see it. I see it. Let me look at this. 15 and 11. I see it. Is it really going to create that big of a difference? No. There's that. Lucy should put the exclamation mark error. I haven't had that on lately. Yep. Yeah, that was it right there. Just one mathematical error. I think I was thinking of the 26 and I wrote 16. That would probably one I wouldn't be give the points back on. Like that'd be one of those mistakes that if you make, oh, I think you were pointing it out. Yeah. 4.6 was right. So we got to turn on the errors here again. We haven't had that on lately. Where's our counter? We're going to do Sydney's question right here, and then we'll come back later and do the other question. No! Like I said, this is the tough one. So please make sure to copy down your numbers correctly right here. Here's 15, here's 11, here's 26, here's 49, here's 4.3. No, try it again, Lucy. I just turned it on, so it should work. Mubot should be counting errors right now. He's happy.
I am Mubot.
He's good. He's doing his thing. He's doing his Mubot thing. So I've only made 14 errors since I was born, so I'd like to think I'm doing well. One of those errors was today, so today's a special day. Stranger Things. So classic Stranger Things intro right there for those who haven't seen it. Let's watch that Stranger Things intro as we get the next question going. Here we go. I want you to be able to know the 5-number summary quickly and easily. As always, least to greatest. Laura, 1,000 points right there. And let's do this.
I found him. What's he doing? I don't know.
The 5-number summary is the following values.
He's talking to someone.
From least to greatest, min, Q1, median, Q3, and the max. Nice answers. If you put the 5-number summary in the chat, you get 1,000 points. Keep these answers coming.
What is it? What happened?
Classic right there. One of my favorite intros too. I think Sydney's question was, is it this one right here? I got a question on chapter 2, question 3B. Okay, so this is Sydney's question right here about how to find it. What you want to do is you want to download Jump. Sydney, have you downloaded Jump, Sydney? I think Layla, you've downloaded Jump. Do you currently have Jump on your computer? If you have Jump, it makes this question way, 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 way easier. Awesome. So here's the steps right here. Let's do this right here. We're going to go right here to this icon, and we're going to go to copy to clipboard. So with copy to clipboard, so tell me if I need to slow down or anything. Be like, okay, stop right here. We're going to go here and hit Control or Command C. That's just going to copy the data. So Control or Command C, Control C on a PC, Command C on a Mac. So now we're going to go to Jump, and inside of Jump, you'll mostly see like a window right here, and the window will just have all this stuff. You'll go to File, New, Data Table. File, New, Data Table. File, New, Data Table. So once you go to File, New Data Table, you'll get the following. Don't click inside of it yet. So tell me if you're right here, Sydney. Are you right here? If you're right here, you're good. I'll wait right here and we'll see where we're at. Especially the first few times using Jump, it can be pretty confusing. So don't worry. What really amazes me is when we do 320, people are really afraid of coding for the first time. Yes, you're right here. Awesome. And then they get good at it. They're like, by the end of 320, they're like, what? You're going to go to Edit, Paste with Paste. We're just going to go to Edit, Paste. My brain went on autopilot for a moment. You're going to go to Edit, Paste. And with Edit, Paste, it's going to paste in the data. We don't have a column name right now. You could technically type in all this data, but so how are you doing right here? It should not have a column up. It should say column 1. Everything's good right there. And then we're going to go to Analyze, Distribution. Analyze, Distribution. I know everyone's always afraid of coding. Lucy, you should, if you're available during summer session 1, Lucy, I'd love for you to talk to 320 and tell them your experience. Stem and Leaf, yeah, that one's, yeah, whichever one you want next, Layla, we will do. Double click right here, click OK, and boom, we got some answers. I just go here to the top right arrow and go to Stack. It just makes it easier to read for me. Once you do the Analyze Distribution, you can go to the top right arrow and go to Stack. How are you doing, Sydney? Are you on this step right here? I can go back. I can repeat steps, whatever you want. I can go back and repeat steps, whatever you like. Are you to this point right here where we have the mean, the standard deviation? You can even go right here and go to Customize Summary Statistics, and you can get the IQR, which the IQR is going to be 18. Awesome. So if you wanted to get the IQR, you could go here and ask it for the IQR, the interquartile range, and it'll give you the interquartile range of 18. That's 55 minus 37. Yes, Lucy, that'd be awesome. Thank you so much, Lucy, because just, I don't know, I love all the positivity, and I want students to know that there's a lot of students who come in like, I don't know if I can do this. Like, I'm not saying you were in that boat, but I think everyone gets freaked out by coding. They're like, oh, this is going to be so impossible. And then by the end, they're like, psh, I got this. And I love seeing that like change over time. So the median for this data set is 47. And that would be awesome. I'd be honored to have you speak to the class. I hopefully had someone speak to your class, because that's always my goal every semester is have, I didn't get a 201 student to speak to this class. I should have. Everything's so quick right now. The IQR is Q3 or Q1 to Q3. So that's Q1 to Q3, 37 to 55. Good. I was a little worried. We got it. Did that work for you, Sydney? Did you get everything correct right there? I'll hop back here to space. I'll go find. Put on a little music. My favorite song. This is my song right here. Nice, relaxing music. Let's go find. Which one did you want us to do, Layla? Which question was it, Layla? You're welcome, Sydney. Thank you so much, Sydney. And you're doing the exact right thing by working on a question, getting stuck, and then just saying, hey, how do I do this? What am I missing? Like Lucy was saying, if you're stuck for more than 5 minutes, ask a question. I mean, it's really quick during mini term. So, you know, like, just when you're stuck, just email. And hopefully I'll be emailing back soon. I haven't caught up from emails from this morning because I wake up, try to answer emails, go and teach class. But the goal is, if you're stuck, just ask questions. Come to office hours, just ask questions. So if you're here right now, you're working, you're asking questions, you're on track. The baseball one and falling back-to-back stem and leaves. You got it. Let's go do the baseball question. We talked about how much we love baseball today, which is a lot. I'm just kidding. There's so many on, so many random questions on this. Baseball, back-to-back, stem and leaf. This is the region one. Don't fall asleep. Where's that baseball one? I'm getting back-to-back stem and leaves, but they're in organization monitors. Which one? I'm getting populations of 2 regions. Can you put in the very start of the question? Can you put in the very start of the question, Layla? So it says the baseball one, and then the one I asked just says the following: back-to-back stem and leaves compares the percent. Oh, change into regions. Okay, that's it. Oh, I think I was combining questions. Got it. Found it. Ready to go. Let's do this. I was combining the other 2 questions. So like a baseball one with back-to-back stem and leaves. I was confused. Baseball team A, you got it. We'll do that one next here. Here we go. So we've got here a unimodal, not skewed distribution, but this is a unimodal distribution down here. And we've got here a bimodal distribution with outliers. There's a tough question down here at the end. Now, the hard part of this question a lot of times is translating this into these box plots. So these are side-by-side box plots, and these are back-to-back stem and leaves. But can you tell me the highest value in region 1 was what? So look at the way this looks right here. What percent is the highest value in region 1? What percent was the highest value in region 1? So if you look at this right here, what percent was the highest percent in region 1? What percent was the highest percent in region 1? The highest percent in region 1 was what? Oh, you put it into the program? Yeah, actually, you can do that. I'll do it. Oh, if you want, we'll do that. It might be calculated correctly. 12. So that's going to be a good clue right here. Do you see how this goes higher than 12, Layla, right here? Like this one's wrong because it goes higher than 12. So that one's wrong. What's up, Andrew? So good to see you. I do believe you got to block them all. You got to block all those spam calls. I hate it. This one's higher than 12. So we've narrowed it down right now to the 2 following graphics. It's either this one or this one. It's either B or C. And I think you can figure it out using, they look very similar, except this one right here has no outlier, and this one over here does have an outlier. I think it's going, is it going to be C? Let's find out. We can bring it over. I think there's a second thing we can look at. I'm trying to remember the second way. If you look at the values in it, because of the outlier, it might be, I wish it was easy enough to figure out. I know where the fences should be. Here we're going to cheat. This is how to bring it over into, it is between B and C. And there's a second way. It's just escaping my mind right now. I know there's a second thing you can look at with these to figure out where the values are at. Is there, okay, wait. 41. Okay, so 41's right here. Yeah, you know what? I can visually show this. I can show that this is going to be the right answer right here. I am 99% certain right now. Watch me be wrong. So we'll talk about this tomorrow. So when it comes to box plots, when you have a box plot, the whiskers, and we're going to do this exactly, the whiskers can only go 1.5 IQRs. Oh, no, you can't do that. It's changing its size. I don't want to change its size. Wait, move to back. I have lost my graphic. There we go. Okay. So, ooh, it's close, isn't it? There's one. No, it's nowhere near close. You're totally right. It is this one. Because this is more than 1.5 IQRs. And so when you extend this up, this would extend 1.5. We'll talk about this a lot tomorrow. This is a tougher question than it looks. You'd go up 1.5, and that's maybe about a half IQRs. And that's where there's an invisible fence right here. Let me explain what I'm talking about here, because this is pretty complex. But this confirms to me that it is this graphic because 1.5 IQRs is where the invisible fence is. So I'm going to show you visually how this is done because this is a pretty tricky question other than just being like, this is the answer. So let's just go here to age, and I'm going to try to make this data set, or I could just make it this way. Okay. I want you to take a guess. Since I'm only putting in these values, I want you to take a guess of what the IQR would be, Layla. So I know what the range is. Just think the range of this is probably this, but the IQR is probably something about this distance. So although, well, we can change the range. We'll make the range this. The range of this data set is now 4, I believe, but the IQR looks to be about what? If you had to tell me what you think the IQR of this data set is, which is the range of the middle 50%, the IQR of this data set is probably what? Because it's probably about here to about here is the IQR. So once again, let me show it highlighting it. There, about there is the IQR. So what is the IQR numerically for this data set? There we go. What is the IQR for this data set? The IQR for this data set would be 2, exactly. So if we go right here and we look at this data set, we can see that the IQR is 2. So here's Q3, here's Q1. Now, what I was showing a moment ago, which I don't think I was showing very well, this is why I want to do it this way, is a formula I know. The formula I know is the following, and we'll see this tomorrow in the notes. We'll go to automatic recalc. There is an invisible fence where outliers begin, and I can tell you exactly where that invisible fence is. That invisible fence is going to be exactly at 23, which means if I take this point right here in this data set and I move it to 23, I want you to watch this graphic. So watch this graphic right here. Do you see this right here where it went to 23? Do you see how that goes to 23? But what about if I go to 23.001? Watch it now. How did I know it would do that? Do you notice how I knew right at 23 the whisker would extend to it? But then at 23.00001, it changes to a dot. Well, let's go back here to the bottom. I know at 15, this is going to show a whisker. But I know at 14.999999999, it's going to show a dot. I'm using the IQR, and I want you to think what I'm doing with it. What is the IQR right here? The IQR has a value of what? And I can show it here. I'm going to show it visually here. The IQR has a value of what? What is the value of the IQR? The value of the IQR is 2. Exactly. And let's take a look at this and see the formula right here in action. That's how we know it's a certain answer. So there's an invisible fence where outliers begin. This is just where outliers begin. And the invisible fence is right here. And the invisible fence is here. So the invisible fence starts at Q3 plus 1.5 IQRs. And the invisible fence down here is Q1 minus 1.5 IQRs. What is 1.5 IQRs right now? Remember what an IQR was. When we found the IQR had a distance of what? The IQR had a distance of what that we calculated it to be? The IQR had a distance of 2. So what is 1.5 IQRs? So what is 1.5 IQRs? 1.5 IQRs would be what? And this is where outliers begin. It's just an invisible fence that we don't usually draw. It's just where outliers begin. 1.5 IQRs would be what? It would be 3. It'd be 3, right? I think you did 2.5. I think you did 2.5. And so this right here is going to be 20 plus 3. That's going to be 23. And this right here is 18 minus 3. Does this make sense here, Layla, how I found these numbers 15 and 23 right here? So 23 is the upper fence, 15 is the lower fence, and that's how I know if there's a point lower than this, it'll be an outlier. If there's a point higher than this, it'll be an outlier up here. This is where outliers begin and end. Does that make sense to you right here? Yep. So this just tells you, these fences right here tell you where are outliers, or where do outliers begin and end. So where do outliers begin? So where do outliers begin? That's all this tells us. It's just where do outliers begin. It doesn't, we don't use it to draw really. It's done for us. Yeah, I think it's the deeper concept behind it. And we can double check our work on this problem because I'm always like, double check, make sure you get it correct. If you go right here, because we believe it's this graphic, we go right here to copy to clipboard. We're going to copy the data. This one is actually a good bit of work to get it inside of here. You need to go to edit, paste with column names, and we might be able to just go to Graph Builder. I'm going to try something I usually don't try. And we might be able to go right here and do this. We might be able to go here and do this. No, it's wanting to do a second. I didn't think we'd be able to do it. It's not letting us. You have to do the next step, which go to table and go to stack and double click them. I was hoping we would just put side by side. And now we can go to graph builder, and we can put the label here on the bottom, and we can put the data here on this side, and then we can click the box plot option, and there we have it. And all of this work to confirm that that's an outlier. So all of that work right there we did, and we have confirmed that this is the outlier. Now, the easier questions, let's hope we don't make a mistake on. Region 1 is more tightly clustered. Region 1 is unimodal. Region 2 is bimodal. We can see the second peak over here. Around all modes, the distribution is... Region 2 has the outlier. It says fairly symmetric, right? I am worried about this one. Fairly symmetric? Whew! Yeah, they're just counting this as an outlier up here. They're not saying it's really skewed. They're like symmetric. I wish they pulled that dot in a little bit further. Fairly symmetric is the key word. It's not perfectly symmetric, but there's some symmetry there. There's some symmetry around this one. That one's a little off. Fairly symmetric with an outlier. So a little tricky at the end right there. I was a little worried there because sometimes the subjective ones can be the harder ones. But good stuff. The other question was the baseball one. Let's look at the baseball one. Great questions. Baseball question. Put on some music. I love the music. We'll put on this one. Turn it down a little bit. Horse races. Ooh, we should do that one. We should do the horse races one. I can't find the baseball one. What does the baseball one start with? Found it. Here we go with the baseball questions. Similar with box plots. These are side-by-side box plots comparing Team A versus Team B. We can graph this data. We might be able to get some good ideas from it by looking at it. You see, that doesn't look... Some of these just don't look right. Because that should not be an outlier. So, Layla, we can eliminate some of these pretty quickly because outliers begin where, Layla? So you'd have to go how many... So I just want you to think about this right here. When you look at these box plots, outliers begin, which you can just do this by looking at it. Outliers begin where? How many IQRs above? How many IQRs above Q3, which Q3 is right here. See how I made it? This is the IQR. I'm holding it. And I've just went up how many IQRs right there. Because if you talk about where outliers begin, above Q3, they should begin at how many IQRs above Q3. And this is what we were just talking about a moment ago. So check out the previous one where we drew out where outliers begin. And we did this all right here. We worked out where outliers begin. So we know where outliers begin. 1.5 exactly. So do you see how that point right there is barely even like one IQR above Q3? Does that make sense? This is an IQR from here to here. And that point, maybe at most an IQR above. So you see that one's wrong. Eliminated. Gone. This one right here, these two are the same, so these both are eliminated. Okay, we're down to these two choices right here now. Uh-oh, it's gonna be tricky. So it has to be that graphic A looks like this. Now graphic B is where it's gonna get tricky. See, I think those are, yeah, that's too far above. Pretty certain it's gonna be this. I'm kind of giving away, oh, you can't see it. Pretty certain it's gonna be this because this is too long of whiskers. We can confirm this again by going here and going to copy to clipboard. We're just going to copy the data. We're going to go here and go to Control C or Control C or Command C, copy the data. We'll go here to jump, and inside of jump, we're going to go to File, New Data Table. Under File, New Data Table, we'll go to Edit, Paste with Column Names. So once we paste in the data right here, we have to go to Tables, and then we have to go to Stack. Actually, you know what? We were only really concerned about League B. We only want to know if League B has outliers. So guess what? We could just go here to Analyze Distribution, go to League B. Now, this is the game for League B. We want to look at the average runs. And the answer is, it does not have outliers. Wow. The whiskers are really that long. They must be at the outer edge of where they can be, but the whiskers are really that long. If you can see right there, those long whiskers, they're at the very outer edge of what I would think. And we could calculate the IQR right here. The IQR is 0.5. Why is it 0.5? 4.3 minus 3.8. There's the IQR. Times it by 1.5. And there's 1.5 IQRs. And then we go to plus 4.3. And look, it's near the outer edge of it. Does that make sense, Layla, right here? Like the outer fence is right about here. That's where outliers would begin. Somewhere at an outlier for this data set would begin at 5.05 because that's 1.5 IQRs above Q3. And the lower one, the fence is probably a little bit further down. It would be, the lower fence would begin at, yep. And so this is where you really understand the material when you're doing this. 3.8 minus the 1.5 IQRs. And the lower fence is going to be about right here. That's where your lower fence is, where lower outliers would begin. So this is the correct one. There are no outliers there. So there we go. There's no outliers for that one. Write a few sentences comparing the average number of runs scored per game in the two leagues. The distribution of runs scored per game is this in League A. Whew. Is roughly... this one's tough. I wish they made it more obvious. Let's see right here. Is it skewed right or skewed left? I think they're going for... There's a longer whisker. This one's more symmetric. So League B and League B is roughly symmetric. League A is skewed to the right because it's got the whisker pulled out a little bit. Usually you look at whiskers for skew. You made a histogram and looked at them both. Oh, it's such a good idea. Let's go here and take a look. That's the wrong data. You should be able to get a better idea from that. Where did I do the... Did I delete the data? Okay, here we go. So we can make two histograms right here, distribution. I think we can just double click both. Oh, we could have done this. Yeah. Okay. So, see, it's looking like, I guess that's a little bit right skewed. It's by the box plots only. I'm a little worried on the right skew on that one. The typical average runs scored for League A is blank to League B. So it's higher because there you go right there. In League B, the variation runs scored per game in League A. While the variation in average runs scored per game in League A is what to League B? The variation is small. No, it's larger. It's greater than because there's a greater IQR. While the variation in average runs scored per game is greater in League B. In League A is greater than League B. It's got a bigger... Wow. I've done this one so many times, my brain's just breaking on it. The two teams playing for World Championship League A versus League 1, League B, both were at the top of their respective leagues. Did either team score? So you just based those questions off of the line in the middle. So this one right here, this question, the typical average runs scored per game in League A versus League B, that's where you base this right here. Does that make sense for the one I'm highlighting, Layla? Does the one I'm highlighting right here where we have League A is generally higher than League B? I'm trying not to block the question. That's going to be the one in the middle. And then this one, while the variation in League A versus League B, I'm basing it on this right here. Here's the variation. Since we're looking at box plots, I'm going to use the IQR. They look about similar in the range, but the IQR is much bigger right here. So I'm saying League A has greater variation. I'm basing that on the IQR right here. So League A has greater variation than League B. Here's the IQR of League B. Here's the IQR of League A. So, yep. So that's what the variation's being based on right there. Great questions. Please, while I do it, ask questions, and hopefully we get it all right. The two teams playing in the World Championship were at the top of their respective league. Did either team score an unusual large number of games? So both teams scored an unusual. Nope, neither team scored an unusually large number of runs per game. Both teams scored fewer runs in the upper fence. Wait. The two teams playing for the World Championship, League A Team 1 and League B Team 1, both were at the top of their respective leagues. Did either team score an unusually large number of runs per game? So, man, I feel like I haven't done this one. Like, I'm blanking. I feel like... No. See, they're talking about the upper fence right here. I feel like they might change this one recently. League A scored an unusually large amount of runs per game. They scored more runs than the upper fence of League B. Both teams scored an unusually large number of runs per game. Both teams scored more runs than the upper fence for their respective leagues. No. Oh, okay, wait. No. So it's talking about, are they outliers? This literal question, as I look at it, like I've never seen it before. I've done these questions tons and tons of times. All it's literally asking are they outliers? In this instance, it would be yes if we saw outliers here, but there are no outliers. So yes, we got it. Yeah, it is neither because I was overthinking it. I missed one question on one thing and I start overthinking everything. I'm like, one small question. I think the hardest one on here is maybe the skew, because what they're counting as the skew is this longer whisker right here. Does that make sense, Layla, right there? That when the whisker is pulled out, it shows an element of skew. I'll show some other distributions that show this off a little bit better probably. Is it very apparent that this is right skew? Do you see how the whisker is pulled out right here? And do you see the right skew over here? So when you see a longer whisker, that's usually evidence of skew. So in a box plot, so you see the histogram right here and you see the box plot, the longer whisker is going to kind of direct the skew a lot of times. So that's the reason, if you're wondering why I went right skew on this distribution, I saw the little bit longer of skew. Why did I say that distribution A had more variation in it? Because the difference in the, hey, what's up, Nick? So good to see you. You bet. Yep, we're doing mini term. It is mini term. So good to see you, Nick. If you want to show off your points, few people have been swinging by, showing off points. So 201 students are like, what? Tons, like so many points. So many points. Random Nick appears. That's worth another 50 points. Lucy was here earlier. Nick swing by. So that's all right, Nick. And you don't have to if you don't want to. Totally fine. Totally fine. Get some extra points right there. What other questions did you have, Layla? You're always welcome here, Nick. It's just a place to hang out and do work. Hey, that's excellent job right there, Nick. Every semester I change around how the points were. I've gone so crazy with the points for major. I need like a semester to refresh or time to like not give out points to where I don't like give out crazy points. What questions do you have, Layla, here? We'll hop back here to the main screen. There's a question, Layla, that we should do that people are going to get stuck on. Another tough question that I got a lot of emails about. So is skew based off the longer whisker. The longer the whisker, the more it indicates skew. Does that make sense? Like when a whisker is pulled out, I might have some here to show you. Here we go. Let's look at this one real quick. We'll do this problem. That's perfectly, yeah, that's what's the best. Nick, whatever works for you, your plan that works for you is the plan that's best, as long as it works. Notice this 4-cylinder car right here. This 4-cylinder car has a little bit of a what skew. Be careful, remember, right to the high, left to the low, whatever way the tail goes. So this 4-cylinder thing has a little bit of a what skew. This 4-cylinder has a little bit of a what skew. It's a little bit skewed in that direction. Little bit skewed. The 4-cylinder car is a little bit of or the 4-cylinder cars, because these are cars, a little bit of a left skew, a little bit of pull on the left tail there, a little bit pull down in that direction. And then this has a little bit of a right skew because you see a little longer whisker and an outlier. So that's a decent indication of right skew. That one's mostly symmetric. This one's a bit weird right here. The 5-cylinder cars, which I don't even know if they exist, 5-cylinder cars all had the same value. So that's actually a box plot right there. It's just all the same values. You can see something like this. If you make a data set, we're just gonna make a quick data set, and we're just gonna enter in a value like 5, 5, 5, 5, 5, 5, 5. And if we turn that into a box plot, this is a box plot. There you go. We'll change it the other direction so it's not, I like it more vertical box plots. This is a box plot. That's a box plot. So yeah, definitely, let's do it. Let's finish that question. Does that make sense right there, Layla, why this is a box plot? Why is this a box plot right here, and why does it look like that? Because 5 is the what value? When you look at this and realize that this is a box plot, you'd be like, oh, that's because 5 is the minimum, maximum, Q1, Q3, median. 5 is every number. And that's what that is. That's the data for it, and 5 is every number right there. So I wonder if we can change it, and it actively changes. It did. Now you see we're seeing some variation, and you're seeing the box plot appear. So we can start to make it so maybe that won't be an outlier, but oh, now it's not an outlier. We'll put an 11. Now an 11's an outlier. So yeah, you can see more of a box plot here, but if you have all 5, then that's a box plot. It's just that 5's every number, so there's no variation in the data. And that's what Stats analyzes, is variation. The box plots show as the number of cylinders increases, fuel economy tends to decrease. So, and I would say it's less variable. Do you think it's less variable right now? What do you think? So as fuel economy increases, the fuel economy, oh no, it's going to decrease. It's decreasing. The other one just talks about less variability. Oh, is there more? Oh, so it's decreasing and has less variability. I'm going to go with that. I wish they'd remove this one out. They should just take out the 5-cylinder car. Box plots show that as they increase, fuel economy decreases. There's the medians going down, less variable, smaller box plots, generally speaking, yes. That's a little bit tricky on this one, on the bottom one right here. I would remove this out. Like, Mike Pearson, what are you doing? It's very evident with this one random thing removed right here. If you remove this and then you were to look at the variability. So here's the variability. Aside from that outlier, there's the variability, and you can see the variability getting smaller. And then here's the means right here. You can see the means going down, or the medians. Excuse me, I misspoke there. The medians is the line in the middle of the box plot. So the blue lines indicate a decrease in the medians, and the yellow distances indicate a decrease in the everything but the outlier included for the middle box plot right there. And I just removed the 5-cylinder car because I don't think we have much data on that. So I might, in this data set, if I was reporting on it, I might remove the 5-cylinder car because that's like something that's just we don't have a lot of data on, and it's not something we see that common. And do we care about 5-cylinder cars? I don't know. I'm going to find that question that people usually get stuck on. The question people usually get stuck on. We've done the breakfast cereal question. Oh, here it is. I found it. You ready? It's another back-to-back stem and leaf. So feel free to ask questions if you have them. Let's do that second back-to-back stem and leaf right here. A consumer organization compared gas mileage figures for several methods of cars made in country A versus country B. And here's the following data. So people usually get stuck on this. Can we do the one that says 3 class all same test history? Yeah, I'm gonna do that one instead. Let's do it. Walk back here to the main screen. Let's do that question. I like that one a lot. Here we go. Let's hop into that question. So this one wants us to take the histogram and also compare it to the box plot. So histograms are univariate quantitative displays of data, and box plots are also univariate quantitative displays of data. So we're looking over here at the first one. So which one is class 1? Class 1 is what's skewed. And actually, Layla, what we've been covering is really going to help out with this. Class 1 is what's skewed. So this is really going to help out with this. Class 1 is what's skewed. Class 1 is what's skewed. And so we were just talking about how this works. Like, oh wait, then we'll pick this one right here. Not that one. Oh, that one right there. It's left skewed. So what do you think? It's A, B, or C? So remember how the tails work on the whiskers, that when it's skewed, you'll usually see an elongated tail in that direction. So do you think it's A, B, or C? So remember, the skew is going to be indicated oftentimes by the tail. So A, B, or C? Which of those would indicate a left skew? So remember, the tail is going to go in the direction of the skew a lot of times. Definitely. Great job right there. Definitely. And now we get to probably where things get tricky. We get to class 2, and I'm not selecting that. I want to deselect it. Okay. Here's where things get tricky when we talk about class 2. But I want you to think about this. If we're talking about how far out the data is spread, then which of these would have a greater range to the middle 50%? Class 2 or class 3? Which of these would have a greater range to the middle 50%? Like, if you were to push the middle 50% out, would it be class 2 has a greater range to the middle 50% or class 3? Which of these would have a greater range to the middle 50%? Class 2 would have a greater range to the middle 50% of the data, or class 3 would have a greater range to the middle 50%? Hey, what's up, Tyler? So good to see you here. Just saw that, Tyler. So good to see you swinging by. Class 2 is going to have a greater range to the middle 50%. Imagine this. You see how imagine you like make a sandcastle and then I go and like squish it down. Then that's going to spread out the data. Does that make sense, Layla, right there? Like if you have like this sandcastle built up and then I go like that, then the data is going to get spread out further. So what answer do you think it's going to be, knowing that we're talking about class 2 right now and it has a greater range to the middle 50%? It's like you had this sandcastle and I went and just, it's going to flatten out. So it's going to push the data out towards the edges. So the middle 50% is going to have a greater range. Do you think the answer is A, B, or C right here? Do you think the answer is A, B, or C? Because the middle 50% is going to have a greater range to it right now. It's going to have a greater range to it. So this has a smaller range to the middle 50%. This one has a greater range, like I flatten out the data. It'd be B, actually. So don't worry, though. It'd be B. So this is the range of the middle 50% here. And do you see how this is really tight in this area right here? But this one's more spread out for the middle 50%. The middle 50% would be more spread out across the number line here. But do you see how this one's more tightly clustered in this area? Does that make sense when you see this right here? Like that's where the middle 50% is at. And it's more tightly clustered in this area, where this one's more spread out along a larger number line. So that will make the final one here, which one corresponds to class 3, it's going to be the tighter cluster one right here. And I think, did they change the way the orders are? I think they did. Yep. So that's got it. Awesome work right there. How are you doing on your quiz, Layla? Have you gotten 100 on this one also? Keep getting those hundreds. Keep just work on them. Ask the questions. I think we have time for at least one more. Yeah, no, it's good work today, everybody. Yeah. We'll hop back to space. Oh, I just about to submit it. Tell me how it goes. Tell me how it goes. Got the music playing. Might get a second coffee right here. Gonna check out some emails in a moment. Hoping it's 100. We will find out. If you have questions right now, let me know. Great job, Layla. Great job. Excellent work. It's I'm really happy. Like, it seems like you're kind of just it's tough. I realize I worry with mini term. I'll be emailing people like probably tonight and tomorrow if people aren't keeping up with the work. But isn't it like right now we would be at the start of February for last year. Like that's how far into the semester we already are. We're like 13% done with the semester. Tomorrow we'll be almost 20% done with the semester. Actually, I think we're exactly 20% done. Am I right? 150, exactly. Tomorrow we're 20% done with the semester. What? Well, you're doing the right things. You're doing the right things. How do you feel the workload is right now, Layla? Like, this is way too much. I'm burning out. Or like, No, I'm just doing the work, following along. Yeah, no, I'm really glad to hear that. And like by working ahead, when you hear these things in class, you're reviewing, and if you're taking notes, mini term is just one of those things where it's an everyday thing. 3 weeks, every day. It's kind of like awesome. Glad to hear that. I definitely know some people feel the stress of mini term. It's a tough. It's like it's an everyday thing. If you take a week off in mini term, you just took a month and a half off of the semester. If you take a week off in mini term, you take a month and a half off of school. It's a lot of time. So with that, it is the end of office hours. Great job, Layla. Yeah, I think working ahead definitely helps. And keep remembering that. And whenever you're stuck on something, we'll play one more song right here. We'll play one more relaxing song. If you're spending a lot of time working on something, it's just not making sense, just put it up, especially if you're working ahead. So, like, the material will get a little more difficult. Like, we'll start covering things like t-tests and things like that. But whenever you're stuck, just email me. Just ask during office hours, hey, Brian, can you work this problem? Can you re-explain this concept? We'll go back over it. I'll try to figure out what I can do to help with the understanding. But, yeah, if you ever feel like you're stuck, just be like, I'm going to wait a moment on this. I'm going to contact Brian. I'm going to see if I can get help on this. But that's where working ahead helps, because if it's the night the assignment's due and you're stuck, well, you can still email me, but if there's an hour, yeah. Well, no, great job, Layla. You're doing excellent. I'm proud of everybody. So if you're watching this video, you're doing the right thing too. You're practicing. I will see everybody later in class tomorrow. But as we say, bye for now, everyone. Bye. Bye, Puppet Shark. You need to appear more in class. You're not on the screen. Tiny Puppet Shark is, though.